Question 1. Express correct to 3SF 0.003597. SF simply means non-zero digits from the left. So the first three non-zero digits from the left we must consider 9. Consider 9. 9 is the third non-zero digit. The next number is 7. You round 7 up to 1. You add it to 9 becomes 10. You put down 0, you carry 1. You add the 1 to 5, it becomes 3. Becomes 6. Becomes 6. So you have 0.00360. C is the correct option. Question 2. Evaluate 0.064 to the power of minus 1/3. What to do first is to convert this decimal number to or decimal fraction to ordinary or common fraction. That is 64/1000. From the negative index of indices, for this sign to disappear, you can invert this fraction to 1000/64. So what you have here is cube root. To do that easily without calculator, you can express 1000 such that the power is 3 to take care of cube root. You do that for both 1000 and 64. So you have 10 square, 10 cube over 4 cube to the power of 1/3. So if you factor out this power of 3 from the numerator and denominator, when it multiplies 1/3, you are left with 1. So you have 10/4, which reduces to 5/2. 5/2. A is the correct option. Question 3. Solve y plus 1/2 minus 2y minus 1/3 equal to 4. Solution. This is what you are asked to solve. I always prefer clearing fractions, and to do that you multiply through each term by the LCM of the denominators 3 and 2, which is 6. If you multiply the first term by 6, you are left with 3 multiplying y plus 1. If you multiply the second term by 6, the LCM, you are left with 2 into 2y minus 1. You multiply the right hand side with 6, you have 24. If you open the first bracket with 3, you have 3y plus 3. If you open the second bracket with minus 2, you have minus 4y plus 2. Minus 2 times minus 1 is plus 2. You add the like terms in the left hand side, you have minus y plus 5 equal to 24. If you collect like terms, minus y is equal to 24 minus 5 minus y is equal to 19. To get y, multiply through by minus 1. So y is equal to minus 19. B is the correct option. Question 4. Simplify correct to 3SF 27.63 squared minus 12.37 squared. You can do this easily with your calculator, but assuming you don't have a calculator, you have to go by difference of two squares. So by difference of two squares, If you factorize, you have this and this. When you subtract, you have 15.26. If you add, you have 40. If you multiply, you have 610.4. So to 3SF, we consider 610. The next number is not up to 5. You round it down to 0. So you have 610. D is the correct option. Question 5. If 7 plus y is equal to 4 modulo 8, find the least value of y in the range 10 less than equal to y less than equal to 30. So let's solve for y first. Collect like terms in this place. You have y equal to, you transfer plus 7 becomes minus 7 plus 4 modulo 8. Y is equal to minus 3 modulo 8. Now modulo 8 has 8 elements or residues from 0 to 7. So minus 3 is not an element in modulo 8. If you deal with that first, you simply add 8 to minus 3, that gives you 5. In other words, minus 3 is equivalent to 5 in modulo 8. Now, the least value in the interval is simply that number that modulo 8 will divide to give a remainder of 5, and such number is 13. If you divide 13 by 8, you have 1 remainder 5. The least number is 13. So B is the correct option. Question 6. The set T is a set of prime numbers. The set M is set of odd numbers. They are all subsets of the universal set. This so that S lies between 0 less than equal to S less than equal to 10, and S is an integer. Find T complement intersection M complement. By this given range for universal set, we have 1 and 10 inclusive because S is strictly less than 0. So you have this as universal set. From this place you define set T, that is set of prime numbers. Prime numbers are numbers with 2 factors, 1 and itself. From that 1 to 10, you have 2, 3, 5, 7. Then M, odd numbers, numbers that when 2 divide them, there is a remainder of 1. Such numbers are 1, 3, 5, 7, 8. So let's get T complement. T complement means the element in the universal set but not in set T, and you have this element. The M complement, the element in universal set but not in set M, so you have this. So the intersection of T complement and M complement is what both sets have in common elements, and you have 4, 6, 8 and 10 and 10. So by this we have A is the correct option. A is the correct option. Question 7. Evaluate log 9 base 3 minus log 8 base 2 over log 9 base 3. Solution. You have the given expression. You cannot Simplify the numerator using the law of subtraction or quotient because the bases are different. To continue, you need to express the numbers so that you have results common to the given basis. To do that, you write 9 as 3 square, then 8 as 2 cube. You have 3 square here also. From the power law of logarithm, the powers 2 and 3 are used to multiply the respective term from behind. So power 2 is used to multiply log 3 base 3. Power 3 is used to multiply log 2 base 2. You have the same thing here. From one of the laws of logarithm, the logarithm of its own base is 1. In other words, when the number and the base are the same, if you take the log, you have 1. From here, you have 1 times the coefficient 2. You have 2. 1 from here times minus 3. From here now, you have minus 3 over 2. If you subtract from here, you have minus 1 over 2. The correct option is D. Question 8. If 2, 3 base y is equal to 1, 1, 1, 1 base 2, find the value of y. You simply convert both sides to base 10. 10 is the common base. And to do that, you multiply each digit in both sides by the respective base and you attach the position of each digit to the base starting with 0. So the position of 3 is 1, position of 3 is 0, position of 2 is 1. Therefore this you have 0, 1, 2, 3. So you have 2 times y power 1 plus 3 times y power 0 equal to 1 times 2 power 3 plus 1 times 2 power 2 plus 1 times 2 power 1 plus 1 times 2 power 0. You have 2y plus 3. Y power 0 is 1, so 3 is remaining. Then 8 plus 4 plus 2 plus 1. When you add up, you have 2 plus 3 equal to 15. Collect like terms, 2y is equal to 15 minus 3, and that is 12. Divide both sides by 2. Y is equal to 6. C is the correct option. Question 9. If 6, P, and 14 are consecutive terms in an arithmetic progression, find the value of P. That is quite simple. In an AP, you always get the common difference. Now the common difference is always constant between any two terms and it is equal. So you have second term minus first term is equal to third term minus second term, and is equal to fourth term minus third term, and so on. In the AP, P is second term minus 6 first term equal to 14 is the third term minus P the second term. If you collect like terms, you have P plus P equal to 14 plus 6 that is 2p equal to 10 equal to 20. 2p equal to 20. Divide both sides by 2. P is equal to 10. B is the correct option. Question 10. Evaluate 2 root 28 minus 3 root 50 plus root 72. Now, one thing about addition and subtraction of solid is that you can only add or subtract similar solid. So going by that, at this step you conclude that you cannot add or subtract. You don't start with that. You have to ensure that the given numbers are expressed in simplest form. Now in 28, you look for one of each factor that is a prime, that is a perfect number. It's a perfect number. The same thing you do for 50 and 72. So you have this problem. 28 can be expressed as 4 times 7 under the root. 50, 25 times 10 times 2, 25 times 2 under the root. 72, 36 times 2 under the root. Now root 4 is 2. 2 times 2, okay, you have it there. 2 times 2 root 7 minus 3 times 5 root 2 plus 36. The root is 6, so you have 6 root 2. If you simplify further, you have 4 root 7 minus 15 root 2 plus 6 root 2. The last two terms can be added, so you have 4 root 7 minus 15 plus 6. You have minus 9, so you have minus 9 root 2. Root 7 and root 2 cannot be subtracted. They are not similar. So C is the correct option. Peter's Simplified Maths. If you are viewing and watching from YouTube, don't forget to subscribe, like and share PSM videos. If you are viewing and watching from Facebook, follow and like the page. Also share PSM videos.